Hi guys, so today we're going to be learning about solving simultaneous equations. It's a topic that comes up on GCSEs every year, and I think it's really important for you guys to have a proper understanding of what simultaneous equations are. So I've split it up into what the title actually means. So solving simultaneous equations, what does it actually mean? So in terms of just a definition, solving means to work out missing values or value. In simultaneous equations case, it's two values. Simultaneous in normal English terms just means doing more than one thing at the same time. So doing something simultaneously means you are doing something at the same time. For example, patting your head and rubbing your stomach. You'd be doing those two actions simultaneously if you were doing them together. And then an equation is usually an algebraic representation of a geometric shape. So the shapes that we'll be using are straight lines. You can also solve equations with quadratics or cubics or with any other line. So in terms of solving simultaneous equations, what it actually means is we are finding the missing values for where two straight lines, so two linear lines, intersect on a graph. So looking at the images that I have currently over here. So I've got figure 1 and I have figure 2 further down. You can see the graphs are written over here and the colours match with the colours of the lines over here, and we're going to start on figure 1. So I can see that I have y equals 2x minus 3, so the grey one, the grey line over here, and the red line y equals 5. I also have that sketched on. And the sentence above, solving where a pair of lines are intersecting at the same point. I'm looking for my point of intersection, so I'm looking where these two lines are intersecting. I've circled it and I've zoomed in and I've drawn my line down at x and I've drawn my line across to the y-axis to find my point of intersection, which is this point over here. So my points for this one, these two lines would be intersecting at where x equals 4 and where y equals 5. And I think what's important to remember is that this is a graph. So final answers should be in the form of, well, what are the coordinates of that the final place where the lines intersect? What's that final coordinate? So in this case it's 4, 5. So I'm just going to write this out. I'm going to make sure that my x coordinate is 5. Sorry, I'm going to make sure that my x coordinate is first even, and I'm going to make sure that my y coordinate is second. My pen is a little bit too thin, so we'll just do that. 4, 5. So moving on to figure 2, the same kind of representation again, where I have two lines. I have y equals 2x minus 3 in the grey, and I have y equals 5x minus 6 in the red. Finding the point of intersection, so the point where the two of them cross over, zooming in, just in case it's hard to read, putting my line up to the x-axis and across to the y-axis, finding my point of intersection, which in this case is at x equals 1 and y equals negative 1, making sure I write that as a coordinate for my final answer, because my final point of intersection is a point on a graph. So, a few notes from the graphs. We can see that our final answer should be the point of intersection, therefore our final answer should be a coordinate. And I think it is crucial that you are shown graphical representations right at the start of simultaneous equations, because it will help to enforce two things. So one, it'll help to remind you that you are working out two missing variables, because that's often a mistake that happens. People do half of the working out and then forget to work out the second variable. And it will remind you to set out your final answer as a coordinate, because that's what you're working out. You're working out the coordinate for where the two lines intersect. So traditionally, how does it work? So I've broken this up into traditional solving equations, simultaneous equations, how I like to solve simultaneous equations, and then I've set an example at the end that we can go through properly at the end. So this I just want to do it as a walkthrough. So finding the first variable, I believe teachers give two options. They will either say you can pick which variable you want to make the same, or they will encourage you to use the second variable. So normally y's or whatever letters happen to be there, but they will normally encourage you to use the second variable because the signs are already written in front and you can physically see the signs. You can see the signs in front of these numbers. And I understand the reasoning behind that. However, I don't think it makes that much difference which way around you do it. I think it is good practice for you guys to know that actually it doesn't matter what order you do these in, providing you remember to write your coordinates the right way around. So personally, I would encourage students to apply basic skills of highest common factor and lowest common multiple by letting you guys pick which ones you want to make the same first. So in this scenario, if I'm just looking at this, I've got 2x and I've got 1x, I've got 3y and I've got 2y. The easiest way for me to match up one of these variables, I could either look for a common factor or a lowest common multiple for 2 and 1, or I can look for a common factor or a lowest common multiple of 3 and 2. I know from these two equations that I can get away with just multiplying this second equation by 2, because then I will have 2x on the bottom and 2x on the top. So that's what I've gone ahead and done. So here, this first equation has stayed exactly the same as this one. The second equation, I've doubled all three terms, making sure that I've kept the right signs in the right places. So I had plus 2y and negative 6. I've now got plus 4y and negative 12, and also I've got 2x to make sure that these are now the same. I then encourage my students, I would encourage you to physically circle which ones are the same. So you can physically see which ones you are working with, and you can physically see which ones you have cancelled out. I know it is hard, and I know a lot of people don't like to show working out. However, I think rather than you trying to remember as much as possible, it is just easier to get it down on the sheet of paper, or in my case, my iPad. So once I'm in this scenario, I have I have one new equation and one old equation. My question now is, how can I eliminate 2x? Because the whole point of this is working out these two missing variables. I have to do them one at a time. I'm using both of these equations together, and I'm working on these equations at the same time, but I have to do each variable individually. I've now got these the same. Well, I want to eliminate the one that I've just got the same. I've just matched them up for that reason. So how do I go about eliminating it? Well, my two questions to you would be, well, I can either do 2x plus 2x, or I could do 2x minus 2x. Which one's going to give me an answer of 2x minus 2x? I'm hoping that you guys are going to say the subtraction one. Therefore, I have subtraction signs in the middle to show that I am doing the subtraction. I'm going to put in a column line, I'm going to set it up that way, and traditionally you can do the top one, take away the bottom one, or the first equation minus the second equation, or you could do the second equation minus the first equation. Doesn't matter, you can do the subtraction whichever way you want to do it. In this case, I've just done it the way it's written, so 2x, take away 2x is 0, filled it in, minus 3y minus positive 4y. That might be something that you might be encouraged to write out. So if it's, you might want to write out minus 3y minus positive 4y, just so that you can see what signs you have, so you can deal with the negative signs. It leaves me with negative 7y. And then 16 minus negative 12, again, may well be something that you might want to write out, just to make sure that you get the correct signs and you do the correct sum in the end. So I should be left with negative 7y equals 28. Just a note, I would place the 0 in, as it can be used to check your answers. So just in case you're going back through your working out, just to double check your answers, or if you have got one wrong, or you have got it wrong following doing this, if you're doing it at the same time as me, it's easy for you to go back and see where you've made that mistake if you've filled it in. I also think it's good practice, because the whole point of this method is called elimination method. Therefore, you should be eliminating something. You should be getting to 0 on a final answer. So I have now negative 7y equals 28. And I'm just going to solve that like a basic equation. I've written it out again just so you can see. I like to set up my divisions as fractions just in case I don't end up with a whole number. In this case, it's not a problem. I do end up with y equals negative 4. That's my first coordinate done. Finding the second variable. So at this point, you've found out what one variable is, and you're now working to see how to work out the second variable. And 9 out of 10 times you will be told to pick an equation and substitute in your value. Fine if you are very good at substitution. However, I know from my classes, students struggle with substitution and they struggle with negative numbers. So I do think that you can use elimination again, and you can. I think students are very good at elimination, and I think they prefer that as a method. Therefore, I'm going to talk to you first about the substitution and the traditional way of doing it. So in this scenario, picking an equation and substituting in the value that I've just got. So these are my original equations, these two. And the one that I'm going to pick is x plus 2y equals negative 6. It's got the smallest numbers and also it's got the positive sign with the value of y. I'm going to then use my value of y equals negative 4, what I've just worked out. X plus 2y equals negative 6, so I've got x, I've got plus 2, and where the y was, I'm subbing in my negative 4, still equals negative 6. I'm going to solve this. I've simplified my signs as well, so I've got x minus 8 equals negative 6, plus 8 plus 8, x equals 2. So my final answer should be x equals 2 and y equals negative 4. Again, setting this out as a coordinate, as remember right from the start, the whole purpose of these was to find where two lines are intersecting. Now, very good method and it works and it's taught a lot, therefore by all means. However, I do think there are a few mistakes that happen with these, so few notes. The most important one, and the one that I see the most, is where students forget to work out the second variable. That's because they've done so much work to work out the first one. Students just forget because they don't know what the simultaneous equations are representing. They don't really know what or why they are doing something, so they don't understand why they are finding two values, why they have two missing numbers, and because of that they do a fair amount of work working out the first value and then suddenly they stop because they think they've got to their final answer. Second thing, substituting into the incorrect variable. What do I mean by that? I mean over here where we got a value of y equals negative 4 and I substituted it into where the y was. Often I will see students subbing in the negative 4, in this case wherever the x is. They don't pay attention to which variable they've actually worked out, so that's often a mistake. And thirdly, just because the substitution can go wrong. So me personally, a new way of thinking, double elimination. So using the same example, all this first variable is all the same. So I'm still going to get y equals negative 4 the same way. However, I'm then going to repeat this process to find the second variable. I'm going to do another set of elimination because students like multiplication. Students are usually good at multiplication and they usually enjoy doing multiplication. So setting this up, I found the first variable, it would be exactly the same as the way I'd done it before. So y equals negative 4. I'm going to repeat this process now. So now these were my original equations in blue. I already made the x values the same for this one. So the values now that I'm looking to make the same are the y values over here. So I have to now work with these values. So I have 3y, I have 2y. Again, the signs for the moment, I'm not ignoring them, I'm going to keep them there, but I'm just going to pay attention to my numbers at the moment so that I can find a lowest common multiple. Lowest common multiple of 3 and 2 would be 6, so the top equation would need doublings, hence I've written the times 2 in each scenario, on each term even, and the bottom equation would need multiplying by 3, so tripling the equation, so underneath each term I've written to multiply by 3. Just put here students are confident and competent at multiplication. That's because you guys usually enjoy multiplying and students are usually very good at it. So I do believe that it's a nice method for students to use because it allows them to use a skill in mathematics that they are already confident with. So these are my new equations. I have 4x minus 6y equals 32, 3x plus 6y equals negative 18, and again, I've highlighted what I've actually had the same, which is my negative 6y and my positive 6y. I'm asking the same questions. How can I eliminate negative 6y and positive 6y? I could do the subtraction either way. I could do the first equation minus the second equation, or I could do the top equation minus the bottom equation, or I could do it bottom minus top, second minus first, whichever way suits you. Again, I've just done it the way it's written, just to keep this a little bit simpler. So I've done negative 6y and I've got positive 6y. My options are I can do negative 6y plus positive 6y, or I'm going to do negative 6y minus positive 6y. To get to 0, to eliminate this variable, I need to add on an extra 6y. So I need this sign in the middle to stay positive. Therefore, this is the option that I'm going to go for. Hence, I want the addition in the middle of these two equations. My new equation that I'm going to have after that, 4x plus 3x is 7x. Negative 6y plus 6y is going to give me the 0. Again, I put in a plus or a minus. The sign doesn't matter, because if you're adding 0 or taking away 0, it will not change your answer. 32 plus negative 18 should end up as a subtraction. Again, if you need to, write out the equation, write out the sum by the side, equals 14. 7x equals 14. Basic solving equations, divide by 7, therefore x equals 2. So again, you can see we end up at the same point. So my final answer should be x equals 2 and y equals negative 4. Setting it out as a coordinate, 2 and negative 4. So I've just put a little note here. So although the initial setup is difficult, what do I mean by that? I mean getting this correct. Getting the scaling of these equations correct is more difficult and takes more time and has more working out required to it. It's using skills that you are already confident with. So using multiplication and using something that you are very good at normally. It's using skills like highest common factor, lowest common multiple. It will encourage you to use and to be confident with negative numbers and obviously multiplication. But after that, once everything has been set up, this is then just an elimination method. Yes, negative numbers are going to be hard. Yes, negative numbers are going to trip you up, but that's going to happen in both methods. You're potentially going to find them difficult either way. I do think this is best because it's one method for the whole simultaneous equation. You don't need one method for one for another. I think if you are more than confident with substituting, I think this is very effective and very quick. However, I know from experience of teaching that students struggle and they don't know why they are why they are using two different methods for one sum. So, quick tutorial. So, new set of equations. I'm going to set this up, and this time around I'm going to do my working out in green so that it stands out. So I've picked an example where neither set of variables are the same. So I have 5x plus 3y equals 16, 4x plus 4y equals 24. So my x values are different, my x coefficient of x is different, my coefficient of y is different. So I'm going to have to go about setting these up. So the way I'm going to do this, first of all, I'm going to deal with, again, it doesn't matter if you want to deal with the y variable first, by all means. If you want to deal with the x variable first, by all means. For the purpose of showing you that it works either way, we'll make the y variables the same this time. So I need a lowest common multiple of 3 and 4, which in this case is 12. Therefore, I would multiply this top equation by 4. And I'm going to multiply the bottom equation by 3. I'm going to write down those working outs just so that I can see what's going on. My new sets of equations that I've got, I will just write them in blue so that they stand out a little bit more. So I'm going to be left with 20x plus 12y equals 64. And then I'm going to be left with 12x plus 12y equals 72. And now to go about solving these. So again, what have I made the same? I've made my 12y's the same. Therefore, I'm going to go about figuring out how to eliminate them. So I can either do 12y plus 12y, or I can do 12y minus 12y. The subtraction is the one that's going to give me my elimination. So I'm going to eliminate them. I'm going to set up my column method. I'm going to set up the line. 20x minus 12x is going to leave me with 8x. Again, I'm going to put in my plus minus. I'm going to put in my 0. 64 take away is 72. I'm going to be left with a negative number, but it doesn't matter. I'm comfortable and I can deal with them. I'm going to be left with negative 8. Again, once I've got that, I'm going to write out the equation that I've just been left with. So I don't need that 0 in there, so I can write the equation without it. So I'm left with 8x equals negative 8, and to solve this, divide by 8, divide by 8, x equals negative 1. Done. Nice and easy. So now to work out the second variable, I'm just going to write out my equations again in blue. I'm going to do the same thing. I'm going to write out my original equations this time round. So I'm going to have 5x plus 3y equals 16. And I'm going to have 4x plus 4y equals 24, and we're going to go about working these out. So again, I'll do the working out for this one in a different colour so that it stands out. So we'll go for purple. So in this one we made our y values the same. So we ended up with 12y's. This time around we need to match up our x values, so therefore we're going to be looking for a lowest common multiple of 5 and 4, which in this case is going to be 20. So this one I must be timesing by 4, and the bottom one I will be timesing by 5. So my new equations that I'm going to be left with, I'll write them in blue just like I did before, so there's some consistency. Not too sure why it's decided to do that, so we'll go with 20x plus 12y equals 64. And we'll go with 20x plus 20y equals 120. Nice. So I'm going to do the same thing when I'm solving this. I'm going to look for which variable is the same, which is my 20x. I'm going to circle that. I'm going to figure out how I am eliminating it. So I'm either doing 20x plus 20x, or I'm doing 20x subtract 20x. The subtraction is what's going to give me 0. So I'm going to put in the subtraction, I'm going to put in my column method just for the purpose of presentation. So 20x take away 20x is going to give me the 0. For this scenario, because when I'm looking at it, I can see that 12y is smaller than 20y, 64 is smaller than 120. For this equation, I am going to do the bottom equation, so the second equation, subtract the top equation, subtracting the first equation. So in this scenario, I'm now going to do 20y take away 12y, which is going to leave me with positive 8y. I'm going to put in the positive sign. And then 120 minus 64 is going to leave me with 56. So my new equation is 8y equals 56. Divide by 8, divide by 8. Y equals 7. So my final answer, if I was writing this out, x equaled negative 1, so I'm going to write this out as negative 1, 7. So you can see the initial setup of this was difficult, but I also had to do the same scenario over here. However, working out my final answer was just as easy, not a problem. So I do think double elimination is the way to go. Obviously, it's a matter of choice. Whichever method you prefer is the one that you should work with, because it's the one that you're going to get the best results with. But personal preference, I do believe you should be looking and aiming for double elimination. Thanks.